Okay, thank you for your very kind presentation. I hope that everybody can hear me even without microphone. So I'm Luca Mannella. This is the title of my presentation. So let's start with the outline. So I'm going to introduce you my research topic, and I will give you a bit of context about the Internet of Things technologies. Then I would explain you the manufacturer user description standard, which is requirements for the research activity that I'm carrying on right now, and then a bit of current and future work. So the goal of my PhD is simplifying the development of more secure IoT systems. And to achieve this goal, it is necessary to understand how security is perceived by IoT developers, and even try to improve security awareness when it's possible, and provide developers guidelines or best practices that can help them in produce more secure software, and obviously creating also or expanding some tools or supporting software that can help them in programming more secure and reliable IoT application. And specifically, the focus of my research activities are on novice developers or developers with limited experience in IoT or security fields. So the main concept, the main subject more related to my research activities are these three. So obviously cybersecurity, which is to defend something, which is cyber, which is ICT. The human-computer interaction, where human in this case is more the developer respect to the final user, which is usually considered by human-computer interaction. And then we have the Internet of Things. Just to be sure that we are all on the same page, with IoT I mean a distributed paradigm where there are a set of interconnected devices embedded with software, processor, sensor, actuators, stuff like that, that can exchange data over a network, which is typically the Internet. So IoT systems are still in a critical situation nowadays. They are very widespread. We reach more than 12 billion active endpoints, but unfortunately sometimes these devices are not yet adequately protected, and it is also well known that a compromised device is not only dangerous for itself, but it could even affect other IoT devices or even other devices in general. Let's think for instance to the distributed denial of service that are that happened a few years ago, very famous, like the Mirai botnet. And we have also to consider that developing secure system is challenging for programmers, especially if they are novice, and particularly in this distributed and diversified environment which is the Internet of Things. Moreover, some vulnerabilities are not always a consequence of a cracker's ability, but they are caused by insecure or misconfigured application. So let's think about a smart home scenario, for instance. If we have a user that would like to control a bulb designed just to illuminate a room, it is quite common that this kind of device is integrated through smart home gateway that the user can control with an app. In the home, it's reasonable that we have other smart devices, for instance the smart fridge, and naturally it does not have any sense that the lamp can talk with the fridge. I mean, or even worse, that the lamp can talk with external services like social medias, unless you want to create a very strange application that informs all your friends when you turn on a light, which is basically useless. But if the lamp can interact with these devices, the attack surface is major, is bigger. So to try to avoid this kind of scenario, the Internet Engineering Task Force a few years ago proposed this standard, which is called manufacturer user description. And the main goal of this standard is to reduce the unexpected communication to and from IoT devices, defining a proper architecture and a data model. How this is achieved? Through a whitelisting approach. So basically the manufacturer specified the authorized connections, which are called policy, in a dedicated file, which is the mood file, and all the other connections are forbidden. So the intents of mood basically are, as we said before, to reduce the device threat surface, to those communication intended by the manufacturer only, to scale the network policies, because you can create a strategy that enforces the same network policies in many different networks, despite your local configuration. It allows developers to address some vulnerability very fast, because if we notice that a device is involved in an attack, we can add a rule that disallows the device to reach such an endpoint. And these add additional security mechanism in a very low cost, because it's just to add a file somewhere in the web. And this file can also help in express device capabilities or requirements. So just to give you a bit more detail, how does it work? The MAD file is produced by the manufacturer, so each class of device must have a dedicated MUD file. For instance, a MUD file for Amazon Echo Dot or a MUD file for the Philips Hue, just to cite you a couple of devices. And this MUD file is composed then by a set of policies, when every policy defines the endpoints for allowed communication, and these policies are expressed in a JSON object following a standard which is called YANG. These policies are then enforced by the network where the device is deployed. So it is necessary that we have a MAD manager in the local network, and this enforcement then is done by some network equipment that the user should have in the network. So the enforcement is partially left to the local network administration. So just to give you a flow of this process, we have this device that we call thing, and we have the MAD manager in the local area network. In a certain moment, the device will expose a MUD URL, and this can be done through different protocols. When this information reaches the router or the switch in the network, it is forwarded to the MAD manager that then retrieves the MUD file from the backend. Once this file is taken, the MUD manager interacts, for instance, with the router to decide how to establish the rules specified by the MAD manager. And these two components can also be deployed on the same device. So our router can also be a MAD manager. These two functionalities can be embedded together. So MAD is very promising, is a very interesting technology, but unfortunately is not yet much deployed. And this is basically due to the fact, according to some studies, to some researchers, that manufacturers are not creating and deploying the MAD files. So a possible solution that many scholars and researchers already proposed is having a third party that generates the MAD files in place of the manufacturer. And in our proposed approach, here you can also find a link to the paper that will be discussed in a couple of months in a conference. Our proposed approach is that a suitable third party could be a smart home gateway, because it's a device able to coordinate many IoT devices, which has a very important role in different smart homes. And this device is often extensible through plugins. So our proposal is that developers and thinkers could help in creating the MUD files, even if they have limited experience with the technologies, even if they do not have a dedicated server, which is something required by the MAD manager, and they can achieve this goal specifying their plugins endpoints. And then we have created an integration for a smart home gateway that can merge together these requirements and expose them to the MAD manager. So how does the architecture change with this improvement? We have the smart home gateway. This gateway can control different integration, different plugins, and these plugins can be functional, so a barely software function, or they can integrate physical device. And among these plugins, we have this integration, which is the MAD generator, that can collect some policies written by the developers and merge them together in a gateway level MAD file. Then when this file is ready, it is exposed as usual to the MUD manager, but this time, instead of going on the internet to fetch this information, the MUD manager retrieves it, always using HTTPS, from the local network. So it has information that is very close to him and very often updated, and then can enforce the policies as usual. So the main contribution of these research activities are the following. We are extending the MUD concept in a transparent way, because we have the smart home gateway that is able to manage the whole smart home, and this improvement is completely transparent for the devices which are not aware to be protected, and even by the mood manager itself that does not know that there is this such mechanism in the network. Then we are also protecting devices that are not natively mood enabled, thanks to developer contribution. We are protecting smart home gateways and their plugin with the MUD standard. This means that we are protecting every kind of plugin, because in this solution, MUD is not protecting directly physical devices, but plugins. So even software functionalities can be protected by this standard. And to test this proposed approach, we developed, as I told you before, a dedicated plugin for Home Assistant, which is a very widespread open source Python-based smart home gateway. Then we are still working on this solution because there is a lot of work to do to consolidate it. For instance, I'm working with some Master's students on several points. The first one is the authentication of the MUD snippets, because we are interested that only trusted developers must be able to add their instruction to the consolidated mood file. So we are creating a mechanism to allow such a control, and we want also that these mood snippets are associated to the proper integration, so that you cannot take a random MUD snippet and associate you with a random integration. We want to have this binding. We are also working on refining the mood policy enforcement at plugin level, so to decide effectively which rule can be enforced by which plugin. And we are also working on the mood policies issue, because here we are merging together several policies, which is very similar to firewall approach. So it is still important to detect policy errors if some developers write wrong policies, or to detect conflicts if, for instance, two policies contradict each other, or if some policies are overlapping, it could have sense to optimize the set of rules to have less rules to be enforced. So this is the end of my presentation. I would like to thank you for your kind attention. You can also have some references to what I discussed so far. I don't know if we will spread a slide or whatever. And if you have any kind of question, I'm glad to answer them. Thank you.